Here we're going to use Wireshark to examine DNS query and response traffic. So start in the Win client. So in your topology, open up the Win client, log in as CyberOps. And the first thing we're going to do is look at the DNS query information for Cisco.com. So we'll go to, once you're in the Win client, open the Toolbox folder, DNS query files, and then open the Notepad. And here you can see the details for the DNS query for Cisco. And then we're going to minimize that. We're going to open the DNS traffic capture from Wireshark. So if I go and we open Wireshark, and then go to File, Open. PCAPs, you should default to this, but if for some reason if it isn't, then it's just in Toolbox, PCAPs, and then the DNS traffic-Cisco. And go ahead and open that up. And then we're going to filter it on the DNS packets, so UDP port 53. UDP dot port equal 53 and hit enter. And we want to find the standard query 0x0002a cisco.com right here. Click on that once. That highlights this packet and puts the packet details down into the details pane. On the source and destination MAC addresses, if we look at Ethernet 2, we can look right across and look at them, or we can go ahead and expand it. And destination has the last 4 digits, 61:A6. The source has the last 4 digits of DA:48. And then we look at our IP protocol version 4. Again, we see the source and destination here, but we can open it up as well and find our source and destination here. Our source IP address is 0.10, the destination being 8.8.8. The source address is the network card of this Win client. The destination is Google's DNS. And then we want to find, we can open up further. So we've got our MAC address. What do we have? With the source and destination MAC address, the source and destination IP address. They want you to check to see if they match what we have on here, if any of them match. So if we go through and open a command prompt, just type CMD there, hit enter. And we could do an IP config /all. And we scroll up and we see our Ethernet adapter, last 4 digits DA:48, which does match. Where'd it go? Up. DA:48 does match the source of this traffic. Now the destination, given the way this capture was made, the destination is going to be different than anything we have on the network. Is the destination the destination MAC address should be, not our destination, let's go down, hold on, what's our destination MAC address? Scroll up. 61A6. So we did our IF config, and then if we go and scroll down, let's do an ARP-A. And I think when you're physically connected, it's a little bit different as far as the destination MAC address would be the default gateway. The way this capture was taken, that would not be the destination MAC address. It is another virtual machine though, as we can see. So it's not the same. This would be the default gateway, and that MAC address isn't the same. So it's a little bit different in the way this capture was taken. You see the destination here is 61A6 as the MAC address. And then we look at UDP protocol. Our source port is 59009 with the destination being 53. Now your source port may be different. because it would be a dynamic port in the upper levels. It's not being used, but your destination port should definitely be 53 because that's the well-known DNS port number. Now let's go ahead and open our DNS or domain name system query details page, and you can open the flags and the queries, and we'll open the www.cisco.com. It is set to query recursively. It's querying for cisco.com. I think that's about it for this part. Now let's go ahead and find the response. So the packet is being sent to Google's well-known DNS, or Google's DNS, one of their public DNS servers. Source port 59009, destination port of 53. The message is set to query recursively. It's looking for cisco.com. Now let's find the response to that. So there's 0x002a query. Let's find that query response. That response packet's going to be here. It says response. And we'll click on that. And we'll go back and just examine our source and destination again. And again, they're going to be flopped, right? Because initially it was the query or the request, and then now we're looking at the response packet. So now the source is the 61A6 MAC address, with the destination being this host MAC address of DA48. Same thing, IP addresses swap. The source is now 8.8.8.8 with the destination being the 192.168.0.10. Look at the UDP. The source port is now the DNS port 53, and the destination port's 59.0.0.9. So they're just flopped. I think I still have everything open. It is set to query recursively, so it can handle recursive queries. And again, looking at response from cisco.com, answers. You can look through here. Cisco.com type CNAME, class IN, and so on. So we've just kind of observed the standard DNS query traffic and the response traffic. And we notice the response just kind of flips. The CNAME and A records should compare to your NS lookup results. And because our topologies aren't connected to the internet, we have a different capture that was already taken and loaded in these machines. So NS lookup wouldn't show on here correctly, but normally they should, when you're doing something like this, they should match. Okay, that's it for this one.